Hi everyone. I'm Rita Sharma, your chemistry teacher, and I'm excited to welcome you to our class.
Chemistry influences every aspect of human life, be it the cleansing agents we use, the clothes we wear, the food we eat, or the medicines we take. Not just that, explosives, fuels, rocket propellants are also chemicals. Isn't it amazing that chemical reactions are the basis of life on Earth and that all our activities are controlled by chemicals? In this unit, we will focus on the three significant areas where chemistry is largely applicable, namely drugs, food, and cleansing agents. Drugs are chemicals of low molecular masses that interact with macromolecular targets and produce a biological response. When the biological response is therapeutic, which means desired and beneficial, these chemicals are called medicines. The use of chemicals for obtaining a therapeutic effect is called chemotherapy. When drugs are taken in safe doses, they act as medicines and are useful in the diagnosis, prevention, and treatment of diseases. However, when the same drugs are consumed in excess, they act as potential poisons. However, never take drugs on your own. Always consult a qualified medical practitioner. Drugs can be classified on the basis of their pharmacological effect, drug action, chemical structure, and molecular targets. Drugs classified on the basis of their biological or pharmacological effects are useful in treating a particular type of problem. For example, analgesics have a pain-killing effect, whereas antiseptics kill or arrest the growth of harmful microorganisms. Drugs can also be classified on the basis of their action on a particular biochemical process. For example, antihistamines inhibit the action of the inflammation-causing compound histamine. Drugs classified according to their chemical structure share common structural features and often have similar pharmacological activity. For example, all sulfonamides have a common structural feature as shown here. Sulfonamides are antibacterial drugs used to treat bacterial infections. Drugs usually interact with biomolecules like carbohydrates, lipids, proteins, and nucleic acids. These biomolecules are called drug targets or simply target molecules. Drugs with similar structures have similar mechanisms of action on biomolecular targets. Drugs classified as per their molecular targets are especially used in the treatment of major ailments such as cancer and tumors. Have you ever wondered why the action of a drug is so specific? How can a drug be targeted at one specific biochemical function within the body? Let's try to answer these questions in this module. Biomolecules such as enzymes, receptors, carrier proteins, nucleic acids, lipids, and carbohydrates perform various functions in the body. Enzymes are proteins that act as biological catalysts in the body. Receptors are vital to the communication system in the body. Carrier proteins carry polar molecules across the cell membrane. Nucleic acids contain coded genetic information for the cell. Lipids and carbohydrates form the structural part of the cell membrane. The action of a drug depends on the interaction between the drug molecule and the biomolecule that it targets. In order to understand the interaction between drugs and enzymes, we first need to understand the catalytic action of enzymes. Every enzyme has a pocket known as the active site or binding site, which enables reacting molecules to bind to it. The reacting molecules are known as substrates. A substrate molecule has a shape complementary to that of the active site of an enzyme and fits into it just like a key fits into a lock. A substrate binds to the active site of an enzyme through a variety of interactions, such as ionic bonding, hydrogen bonding, van der Waals interaction, or dipole-dipole interaction. The enzyme then provides functional groups to react with the substrate and form products. As the products separate themselves, the active site gets vacated, ready to accommodate another substrate and continue the reaction. Drugs known as enzyme inhibitors can block the binding site of the enzyme and prevent the binding of a substrate to it, or inhibit its catalytic action. Drugs inhibit the attachment of a substrate on the active site of an enzyme in two different ways. One way is by competing with a natural substrate for attachment to the active site. Such drugs, known as competitive inhibitors, block the binding site to prevent a substrate from binding to the enzyme. The other way is by binding to a different site on enzyme, called the allosteric site. By doing so, it changes the shape of the enzyme's active site in such a way that a substrate cannot bind to it. An enzyme is blocked permanently if the bond it forms with an inhibitor is a strong covalent bond. In such a case, the body degrades the enzyme inhibitor complex and synthesizes the new enzyme. Now, let us see the drug-receptor interaction. The tissue constituent with which a drug is supposed to combine to produce a pharmacological effect is called a receptor. Receptors are important to the body's communication process. Most of them are embedded in cell membranes. The active site of a receptor extending out of the membrane receives chemicals known as chemical messengers, which pass messages between two neurons and between neurons and muscles. The active site of a receptor changes its shape slightly to accommodate a chemical messenger. Once the chemical messenger moves away from the receptor, the active site regains its original shape. Thus, the chemical messenger gives the message to the cell without entering it. There are a large number of receptors in our body. Each receptor shows selectivity for one chemical messenger over another. This is because the binding site of each receptor has a different shape, structure, and amino acid composition. Based on the interaction with receptors, drugs can be categorized into antagonists and agonists.
Your support through likes, subscriptions, and shares is appreciated. Turn on notifications to stay informed. Thank you.